Hello everyone and welcome to this next presentation, which is all to do with algebraic division. And in the same way that you can divide two numerical values by each other, we can also divide two algebraic expressions by each other. So that is the method that we're going to look at today. And I'm going to show you two methods of being able to do that. One of them is called the box method and the other one is called long division, and you may have seen long division before but with numerical values. You only really need to learn one of these methods, not both of them, so after having gone through both methods, if you practice, you will then be able to decide which one you feel best suits you, and you can use that one from now on. So learn the method that works best for you. Right, good. Let's have a look at the first of those two methods then, which is the box method. Very similar grid type method for those of you who like to use this for long multiplication. Very similar, just using algebra instead. So we're going to demonstrate it by dividing x cubed minus 8x squared plus x plus 42 by x plus 2. So here's the grid that we're going to use. And I'm going to place the x plus 2 down the left hand side, one row for the x and one row for the 2. Obviously if it was minus 2 we would need a minus sign in front of the 2. Then I look to see what I'm trying to get. So the first term I'm trying to achieve is x cubed, and that's going to go in the top left hand box of the grid, and then that's going to enable me to start filling in the rest of the grid. So what would I need to multiply x by in order to get that x cubed? Well, of course, I would need x squared. So that goes at the top left hand side of the grid. So x times x squared would give me the x cubed that I need, and then I can also, from that, fill in the bottom left hand box, which would be 2 lots of x squared, which is 2x squared. Now, that's the x cubed dealt with. I then move on to the x squared. So I want minus 8x squared altogether. I've currently got 2x squared inside the grid. So what would I need to do to achieve my minus 8x squared? Well, I would need to do 2x squared minus 10x squared would achieve the minus 8 that I need. So the minus 10x squared would go in the middle top box, and that will then cater for together the minus 8x squared in my original cubic. As a result of being able to fill in that box, I'm then able to fill in the top middle term. So what would I need to multiply x by to get minus 10x squared? I would need to multiply it by minus 10x. And then that enables me to fill in the box in the bottom middle section. So 2 times minus 10x gives me minus 20x. And then this just continues as I've already done. So I'm then moving on to the x's. So I need a total of 1x. I already have minus 20x, and therefore I will need to add on to that 21x. That then enables me to fill in the top right part of the grid. So what would I need to multiply x by to get 21x? I would need 21. And then finally, that then allows me to write 42 in the bottom right hand corner, because 2 lots of 21 gives me 42. And that just so happens to be the value that I need at the end of my cubic. So happy days, there is no remainder here. It means that x plus 2 is a factor of that cubic. There is no remainder. If there was a remainder, then I will be able to see what that remainder is now by comparing the number in the bottom right hand corner with the number in the cubic. But because they're both the same as each other in this example, my job is done. So that leads to the answer of the cubic equaling x plus 2, and then I've also worked out my quotient of x squared minus 10x plus 21. No remainder, so I don't have to do any more. And if I wanted to, I could of course factorize the quadratic as I was doing in the previous presentation, but I'm just going to leave it like that for now. The other way that it could be written is if I divide the cubic by x plus 2, it gives me this quadratic, and again, no remainder. Okay, good. Now that we've looked at the grid method, we're now going to use the second method, which is long division. Some of you will have used long division to divide numerical values. I'm going to show you how to do it with algebraic terms instead. For consistency, let's have a look at the same cubic being divided by the same x plus 2, and therefore we will get the same answer as the previous slide if we do it correctly. And the way that we set it up is like any other division. We are going to be looking at how many x plus 2's go into this cubic. And to do that, the first thing we do, a bit like the previous slide, is we look at how many x's go into x cubed to start with. So I'm looking at how many x's from the outside of the division sign go into the first term inside, which is the x cubed. So I ask the same question, what would I need to multiply x by to get x cubed? And of course the answer to that is still x squared. I write that above the x squareds that are in the division. So my x squared goes here. So that's step one. How many x's go into x cubed, x squared? What I then need to work out is what will my remainder be by performing that action. So I now need to multiply the x plus 2 by the x squared that I've just found on the top of the division. And that will enable me to find the remainder that's left. So if I multiply x plus 2 by x squared, I end up with x cubed plus 2x squared. And you can see that I'm lining up the x cubes, the x squareds, and I will be lining up the x's and the numbers as well. Now by lining them up as I have done, it enables me to find the remainder. So I'm now going to be subtracting the x cubed minus 8x squared and the x cubed plus 2x squared. So this is just demonstrating that I'm lining everything up carefully, which makes life easier when it comes to long division. And so I'm now going to subtract one from the other. So I get minus 8x squared minus 2x squared is minus 10x squared. Of course, I didn't have to consider the x cubes because they've cancelled each other out. They've gone. And I've also introduced the plus x plus 42. And now I'm just going to repeat the same thing again, but on this quadratic rather than the original cubic. So I'm going back to the beginning and I'm looking to see how many x's go into my minus 10x squared. And if I do the maths on that, I realise that I will have to multiply by minus 10x. So that will go at the top of the division. And then if you remember what we did previous, I'm now going to multiply the x plus 2 by the minus 10x that I've just found. And I'm going to write that underneath. And I will get minus 10x squared minus 20x. And at this point, I'm again ready to do my subtraction to find the remainder. So minus 10x squared, take away minus 10x squared. Be careful, but you get your double negative, so they cancel each other out. Be careful of the double negative again here. So 1x, take away minus 20x is going to become 21x. And then I've brought that 42 down again from the previous step. And I'm ready to start again. So I'm now looking to see how many of my x's go into 21x. What would I need to multiply one by to get the other? Well, the answer to that is 21. So that goes at the top. So I've now got my full quotient. And my final step is to multiply the x plus 2 by that 21. And lo and behold, I get 21x plus 42. So when I do take the two away from each other, I end up with my remainder of 0. very much the same as the previous slide. Of course, if that number was any other value than 0, that would be my remainder. And if you remember our presentation from a while back on factor theorem and remainder theorem, if I had replaced x with -2 into the cubic, then that would also be a way of finding the remainder. But that method doesn't give us the x squared minus 10x plus 21 quotient that this method does. So we can now say that the cubic that I was given to start with is equal to x plus 2, and then I have my quadratic factor as well. And again, if I wanted to, I could factorize that quadratic further into 3 linear factors, which I have done on the next line. And this is just a little note to say exactly what I just said earlier about if you replace x with -2 inside the cubic, it is going to give us an answer of 0. That's our remainder. But this method is quite clever because it also tells us the quotient as well. Okay, good. So it's your turn now. Here are 4 cubics. And I'm dividing each of those cubics by a linear expression, x plus 2, x plus 3, x plus 1, x minus 1. A little bit of advice to you. I gave the same advice on the previous presentation. If there are terms that are missing in your cubic, so if there aren't any x squareds, if there aren't any x's, and even if there isn't a number on the end, I would be making the suggestion that you put one in. So for example, on the bottom one, instead of writing x cubed minus 7x plus 6, when you're doing your box method or long division, I would be writing it as x cubed plus 0x squared minus 7x plus 6 to have all the terms there, even if one of the terms is 0x squared or 0x or just 0 on the end. It makes life a lot easier when you're setting your work out. So that would be my tip for this exercise. Have a go, pause it, and when you're ready to get some answers, click play again and we'll discuss what you've got. Okay, so it turns out that in A you end up with a quadratic which is x squared plus 2x minus 15. And I've gone on to factorize that into the 2 brackets that you see there. There is no remainder, as is the same with B, except we get a quadratic x squared minus 2x plus 1, which I've then factorized into the repeated root you see there. No remainder. Number 3, it turns out that there is the quadratic x squared minus 2x when you divide one by the other. Again, no remainder, and I factorize that to just simply x, lots of x minus 2. And then finally, this is the one where I would be putting 0x squared in to replace the fact that there isn't an x squared term. We end up with no remainder, but our quadratic quotient of x squared plus x minus 6, which factorizes to the 2 brackets you see there. So well done if you got those right. If you ended up with just the quadratic and you didn't go on and factorize fully, do not worry. The fact that you managed to get the correct quadratic is great at this stage. So well done if you got those right. Okay, and to finish off this presentation, as always, there is an exercise from your textbook that you can have a go at on page 26. Have a go at the questions that are there. If there are any problems at all, contact your teacher. They'll be able to help you. And yeah, well done. And that's your algebraic division finished. And I will see you on the next presentation. Bye-bye for now.